All right, welcome to another lesson. Today we're looking at some trigonometry stuff and just doing a couple of examples of symmetry in trigonometry and working out exact values of sine, cosine, and tangent. Just trying to figure out how to do different things and trying to get used to using the unit circle. So firstly, let's draw a unit circle because that's going to be helpful. So we draw a unit circle like this. A unit circle. Let's hope I draw a good one. Look, that's okay. Unit circle, we know it has a radius of 1, making these -1. And what we recapped, or what we should recap, is that we know the sine of theta, that is, if I draw a line, let's draw it in a different color actually. If I draw a line here like this, and I take this angle theta, by definition, sine is equal to the y coordinate, okay, of xy, and cosine is equal to the x coordinate, okay? And then tangent, by definition, is equal to the sine divided by the cosine. This idea of the sine and the cosine being the y and the x coordinates is super, super important because it tells us what happens at the boundaries. The boundaries being those 90-degree angles or multiples of 90 degrees that SOHCAHTOA can't work out for us. Cool? Okay, so we're going to be working in radians. So let's just assume everything is working in radians. Okay. Let's do a couple of examples of using symmetry. Oh, the other thing is we should also remember our exact value triangles. So let's have a look. Let's do them over here. So we have this one, which is sort of the uneven one, where this angle is pi on 6, again in radians, pi on 3, right angle, and we can work out that this is root 3, this is 1, and this is 2. And then we can take one that's half a square. Wow, that was absolutely shocking. Let's do that again. Half a square. We'll take that. Don't get angry at my shaky hand. Pi on 4, pi on 4. Wow, okay. Apologies. Pi on 4. I really need to give myself more space, don't I? Here, let's zoom in. Pi on 4. Great. And then we know this is 1, 1, root 2. And we're going to use those exact values to help us later. Okay? So the thing that we talked about in class, or hopefully we talked about in class, was that the unit circle obeys symmetry. That is, if I take this angle and I rotate it around, I'm going to end up with some congruent triangles that happen with this angle theta inside of them, which means I can just understand or use the fact that sine and cosine change whether they're positive or negative depending on the quadrant, okay? Quadrant 1, 2, 3, and 4. And then I can just figure out what kind of triangle I'm working with. And because they're congruent, we know that the side lengths are the same, hence the sines and the cosines will be the same, barring positives and negatives. So let's do a couple of examples. For the first few examples, I'm going to actually draw the triangle on the unit circle so you can see the way that it relates to the original triangle. And for the next couple, I'm just going to do it fairly quickly so that you can see how, once you get used to it, it's actually fairly straightforward and you can just think about multiples of things. So let's do some examples. The first one is we're going to do some examples of sine and cosine. So let's think about what is the sine of, what's a good one to do? Let's do the sine of 5 pi on 6. Okay? The sine of 5 pi on 6. So if I want the sine of 5 pi on 6, what I need to do is I need to take an angle of 5 pi on 6. Again, everything's in radians, so the faster you can get used to radians, the better. We draw our unit circle. 5 pi on 6 means that my line ends up here, okay? And we know that the full angle is 5 pi on 6, as in measuring from the right-hand side, this green bit, okay? But it means that if I draw this line down here and draw a right angle, it means that this angle in here, let's do all of our angles in blue, this angle in there must be pi minus 5 pi on 6, which is equal to pi on 6. In other words, this is a triangle which has, I'll draw it bigger over here. So our triangle's like this, okay, with an angle of pi on 6. Okay, so it's basically our exact value triangle, right? So we can use our exact value triangle things. We can know that this is root 3, we know that this is 1, and we know that this is 2. Okay, so we know that the ratio that we're looking for is, well, we want the sine, so we want the opposite over the hypotenuse, okay, which is opposite over hypotenuse equals 1 over 2. But now the question we need to ask ourselves is, maybe we'll write this question here just to make it explicit, and then from now on I'll just say it after this question. Is sine theta positive or negative here? And sine theta is measuring the y coordinate, which means the y coordinate is positive. So sine theta is positive here. Okay? So, which means we can take this and we can say that sine of 5 pi on 6 is equal to, now again remember we've got this idea that we know that it's positive. Okay, obviously you don't need to write that in real life, but we're just doing the method. Positive, and then we figured out over here what the triangle was, even though it's been flipped, that's fine. The side lengths are still the same. The sine is 1 over 2. Okay, so the sine of 5 pi on 6 is positive a half. Okay, positive a half. All right, let's do another one. So let's now do the cosine of, let's do the cosine of 5 pi on 3. Okay. Again, let's draw our circle. The more you do this, the less you'll have to draw this circle, because your brain is just going to recognize, okay, where do I get to a horizontal or a multiple of pi? And then how much more am I adding? Which means what kind of triangle am I making? But this is the long way if it's going to be helpful for you. Again, we'll draw our line. 5 pi on 3 is 5 lots of pi on 3. We know that 3 lots of pi on 3 is a half rotation. So we're going to add 2 more, which means we're going to be sort of over here. Okay, I'll zoom in a bit. We know that the whole angle is that, and we want to work out, we know that's a right angle. We want to work out what this small angle is, right? Now, this angle in here, theta, okay, well, actually, theta is a bad way to say it. This angle here is 2 pi minus 5 pi on 3, which is equal to exactly pi on 3. Because 6 pi on 3 is equal to 2 pi, right? So if you don't trust me, just do the fractions. Cool. So we know it's a pi on 3, which means we're going to be working with that other exact value triangle again. So let's write it. This, let's just get rid of that bit. Ugh. Root 3, 2, 1. This is pi on 6. And this is pi pi on 3. Cool. We're looking for the cosine, which means we want the adjacent over the hypotenuse, which is equal to, at pi on 3, also 1 over 2. Similar to last time. Okay. Great. All right, so now we want to figure out what cosine is equal to, but we ask our question. Question, is cos theta positive or negative here? And cos measures the x value. So the x value for this particular one is down here. It is positive. So we know that now we can just use this exact value triangle and we can use the positive version of cosine because we know cos is going to be positive in this quadrant. So we can say cos of 5 pi on 3 is equal to 1 over 2. Okay. Lovely. All right. Let's do a couple more. Let's do one where we're not working from a nice horizontal though. So let's do something like this. Let's find the sine, okay, the sine of, let me just think for a second. Let's do the sine of 15 pi on 4. Okay, 15 pi on 4. Now, the thing that we should immediately notice about this is that the angle is a lot bigger, right? This angle, 15 pi on 4, is much bigger than 2 pi, meaning we're going to be doing a full rotation. So what we need to do first is we need to figure out how many rotations are we actually doing before we end up caring about the angle. So I'm going to rewrite this. And I'm going to say this is equal to the sine of 2 pi plus, actually let's not skip any steps, let's do this. 8 pi on 4 plus 7 pi on 4. Cool? But we know that's also equal to the sine of 2 pi plus 7 pi on 4. And we know that every time we do a full rotation, it just repeats, which really means that it's equal to the sine of 7 pi on 4. Now, that's not the actual value, of course, it's not the exact value, but we've just recognized that these two things here are the same. Okay? So, sine of 7 pi on 4. Now, I'm going to do this by explaining it rather than drawing it, so that way, hopefully you guys can see. It's good to be able to do this in your head without having to draw the whole triangle. Just saves you a bit of time, but we will draw a unit circle. A very dodgy unit circle, my apologies. So 7 pi on 4. I know that pi on 4 is a quarter of a rotation, or of a half rotation, right? So there are 4 lots of pi on 4 in a half rotation, which means, I grab my green one here, I know that 4 pi on 4 will end up with a half rotation, so over here, okay? And then I add another 3 pi on 4, okay? Which means I end up down here. Or it's the same thing as negative pi on 4, okay? I end up down here, and now I could draw the triangle, but again, I'm trying not to. I'm going to draw it on the side here instead. I know that there's an angle of pi on 4 in that triangle, which means I'm going to be using this exact value triangle. 1 root 2, pi on 4, pi on 4. I know that we're using an angle of pi on 4 in here, just to not confuse us too much. I know that's pi on 4, and then that extrapolates to this big triangle over here. I want the sine of it, okay? So the sine of pi on 4 is equal to the opposite of hypotenuse, which is equal to 1 over root 2. And now, again, I ask my question, my question positive or negative? And I know we're in the fourth quadrant. Sine measures the y, which means it's going to be negative. So therefore, the sine of 15 pi on 4 is equal to the sine of 7 pi on 4, which is equal to negative 1 over root 2. Cool? Good. All right, let's do one more and then I think we'll be good. And you can have a go yourselves. So we just did a sine. Let's do a tan this time. So let's do tan of, let's do another bigger one. Let's go 17 pi over 6. Okay, tan of 17 pi over 6. So again, the first thing I want to do, draw a unit circle and figure out where this angle takes me. Okay, I know that this can be rewritten as tan of, I'm going to do this fast, 2 pi plus 5 pi on 6. If you don't believe me, just convert the fraction yourself, which means it's equal to the tan of 5 pi on 6. Okay? Which means I know that my angle, 5 pi on 6, is over here. And it forms this triangle. Okay? Which means I'm working with the exact value triangle that has an angle of pi on 6 in it, which means I'm working with this one. I told my class today that it would be really good to memorize these exact values because you're going to need them all the time. There's almost no reason not to. You'll probably memorize them by using them, but it's good just to think about it more in depth. Pi on 6. Okay. I know this angle in here is pi on 6, which means I want to figure out what's the tan of pi on 6. So the tan of pi on 6 is equal to, well, if we look at our triangle here, it's going to be the opposite over the adjacent, so 1 over root 3. Okay? 1 over root 3. But then again, we ask our question. Question, positive or negative? Okay? And in this case, tan is measuring the sine divided by the cos. So you could figure out whether the sine and the cos are positive and negative, or you could also remember tan measures the gradient. Okay, and here in this quadrant, the gradient is clearly negative because the line is going down. So here it's negative. Okay, which means that we can write from up here our original thing, tan, so therefore tan of 17 pi on 6 is equal to the tan of 5 pi on 6, which is equal to the tan of pi on 6 but made negative. And the tan of pi on 6 was up here, so that's equal to negative 1 on root 3. Cool. All right, so that's how you do symmetry or use symmetry within the unit circle. It really just means you have to remember these exact value triangles up here, and you just need to figure out what angle does your angle actually need. So, reduce it down as much as possible, then figure out what your triangle actually looks like, and then apply the exact value. Hopefully that's helpful. Enjoy. Trig's really cool like this. Have fun.